Hey guys, it's Mr. DeFelice. We're going to work on the station number 3, function notation and evaluating functions. Feel free to fast forward any of the parts that you think you've already got, but I'm going to go through each question so you can get the answers that you can check against your own. So with this one, we're given different functions. We have the f function, h, p, k, and m. So each problem will direct me to a certain function that I should be working on. So let's start off with the first problem. It says find f of 3. So I'm going to look at the f function. F of 3, so 3 is my input, so I look on the x-axis. When I have an input of 3, my output is 4. So f of 3 equals 4. In number 2, it's again having me use the f function, and it's saying find f of 2.5 and see what output it gets, and see what other input for f gives me the same output. So if I go to f of 2.5, f of 2.5 gives me an output of 3. Because right about 2.5, it crosses at 3, so my output is 3. Where am I going to get the same output of 3 on the f function? So if I look at 3, this was 2.5. The other input that'll give me 3 as an output is 5. So an f of 5 gives me 3 as an output. Alright, the next one is asking about the h function. So I look at my h graph. It's asking which input gives me an output of 2. So looking at my inputs, I'm looking for the one that gives me an output of 2, and it looks like it's right at 4. So my input is 4, my output is 2. Okay, let's go to the next one. This one's kind of weird in terms of the notation. It's saying h of blank equals h of blank. So basically it's saying that two inputs are going to give me the same exact output. So let me look at my graph, and I think it's pretty clear to see which ones are the ones that are giving me the same output. It looks right here that in this h function, two of my inputs are giving me outputs of 5. So my input of 1 gives me an output of 5, and my input of 3 also gives me an output of 5. So the two inputs that give me the same output are 1 and 3. Remember, to be a function, all that matters is that every input should have a unique output. So this input 1 only has one output of 5, and the input of 3 also has an output of 5. So that's okay. As long as every input has its own output, we're good. Alright, next one. P of negative 3. So my input is negative 3. I'm going to plug it into the p function. This one's nice and easy. Just plug in negative 3 and then simplify using orders of operations, so I get negative 1. 2 times negative 3 is negative 6, plus 5 is negative 1. For number 5, it's a little bit different. This time it's asking if my input is, what is my input that gives me an output of 11? So the way I look at it, I'm replacing this with what the rule is for p of x. So the rule for p of x is 2x plus 5. I'm substituting in this value for p of x, and now I can solve for x. Alright, that's for p of x. For number 6, it's asking what input for k and also input for p gives me an output of 11. Well, I just did that problem, and I know my input for p is 3. Looking at k, so looking at my k function, which input gives me an output of 11? And 2 is the input that gives me an output of 11. The next one, k of 0. So I'm going to go to my mapping diagram. My input is 0. What's my output? 3. Using the mapping diagram again, what input will give me an output of 5? So if I look at my mapping diagram, what input gives me an output of 5? So there's actually two answers here. Negative 1 gives me an output of 5, and 1 gives me an output of 5. So I'm going to just rewrite this twice. k of -1 and k of 1 each gives me an output of 5. And that's because those two arrows are pointing to 5. Okay, next one, m of -7. So I'm going to look at the m function. My input is -7, so my output is 7. And then the last one, it's asking for the input. What input gives me an output of 3? So looking at my function, my table, what input gives me an output of 3? And right here, 3 happens to be the answer. Alright, so here's all the answers. So you can check and just make sure you got them. If you have any questions, please ask Mrs. Versailles or Mr. DeFelice.